So we now look at the empirical and the molecular formula. Okay? Empirical, and molecular formula. That's what we are going to look at. Okay? And empirical formula simply implies the simplest ratio of the number of atoms. Okay? The simplest ratio of the number of atoms of different elements in a compound. So, in other words, when you are looking at the empirical formula, you are looking at the simplest ratio. Then the molecular formula refers to the actual ratio of the atoms in the compound. So let's look at an example. A substance contains a substance contains 17.7% hydrogen, 17.7% hydrogen, and 82.3 nitrogen, and 82.3% nitrogen by mass. Find its empirical formula. Find its empirical formula. Brackets, hydrogen is equal to 1 and the nitrogen is 14. So to get the empirical formula, this is what happens. We first identify the elements present in the compound. Okay? We look for the elements present in the compound. That should be the first thing which we do. Is that clear? So elements present. Elements present. So what elements are present in this compound? We have hydrogen and nitrogen, isn't it? They have been stated here. Hydrogen and nitrogen. Okay? So, when we are writing those elements, okay? Sometimes there are elements which come before others. For instance, here we don't begin with hydrogen. We begin with nitrogen. So, nitrogen and hydrogen. So, write the symbols of the elements present. Secondly, we follow the percentages. Percentages. If not percentages, if the question stated mass, you state the mass. Are we together? So what is the percentage of nitrogen in this compound? 82.3. It is stated there. What is the percentage of hydrogen? 17.7. Okay? I don't want to see anybody writing. The next thing which we do is to look for number of moles. Number of moles. Number of moles. To get the number of moles, you divide the percentage by the atomic mass. The atomic masses have been given to you. Is that clear? So this gives you 82.3 divided by the atomic mass of nitrogen, 14. Then 17.7 divided by the atomic mass, which is 1. So what are the modules given now? Divide this and give me the modules. Divide this and give me the modules. This will be 17.7. What about this one? Get your calculators out.
5.878.
5.88. 5.88. Are we together? These are the moles. After getting the moles, we get the mole ratio. The mole ratio. Mole ratio is obtained by dividing through by the smallest. You divide through by the smallest. So what is the smallest here? 5.8 is smaller than 17. Okay? So divided by 5.88 divided by 5.88. What is the ratio here? This is 1 to. What is this? 17.7 divided by 5.88. It is 3.0. You round off to 3. Are we together? So the empirical formula is in such a way that nitrogen 1, hydrogen 3. So we can write that formula as NH3. Remember, we don't write 1. Huh? We don't write 1. So NH3. What is NH3? This is ammonia. So this is the empirical formula. Are you together? This is the empirical formula. And you take now empirical formula is unless you have a question, you can ask. But before you ask, I've said to get the empirical formula, these are the procedures. First, identify the elements present in the compound and write their symbols. 2, write the percentages of those elements. If you are given masses, write the mass of the elements. 3, divide by the atomic masses. Divide by the atomic masses. That gives you the number of moles. Are we together? After getting the number of moles, divide through by the smallest number of moles to get the mole ratio. The mole ratio determines the empirical formula. As simple as that. Yes. No, we don't consider the biggest. But I have told you that we don't have any compound which starts with hydrogen. Okay? So, write what is commonly known. We don't have any atom, any compound where hydrogen appears first in the formula. So, that's why I started with nitrogen. Yes.